Hello, welcome everybody. My name is Vince Vidrine, winemaker at Irvine and Roberts Vineyards in Ashland, Oregon. I've got the opportunity to introduce today a really cool session for you guys, a review of grape phenolics and the effects of maceration techniques. We have some really great speakers, and I'll quickly introduce them. First, we've got James Kennedy, who will be followed by Dr. Karen Bindon, of the Australian Wine Research Institute. And then Dr. Kennedy will interview Sam Tannehill of Rex Hill A to Z and Francis Tannehill Wines, and also Michael Terrian of Terrian Wines. Dr. James Kennedy will be first to review the grape phenolics. He is perhaps one of the best people that we could hope to find to cover this. Dr. Kennedy is the principal of functional phenolics, and he is widely recognized for his grape and wine phenolic chemistry research around the world. He has a PhD from University of California, Davis in agricultural and environmental chemistry. He's held positions as associate professor at Oregon State University, where I assume lots of you guys know him. He was the research manager for chemistry at the AWRI in Australia, and also the chair of the Department of Viticulture and Enology at Fresno State, California State University, Fresno, and also the president of polyphenolics at Canandaigua Concentrate. He was a Fulbright scholar at the University of Bordeaux, and he's currently an adjunct professor at the University of Adelaide. He was also a past president of the American Association for Enology and Viticulture, and serves as an editor for associate editor for the American Journal of Enology and Viticulture and Catalyst. So again, a really wonderful person to have with us today. And I hope you guys enjoy. Thank you very much.
Thank you very much, Vince, for the introduction. I'd like to start by thanking the Oregon Wine Symposium Organizing Committee for the invitation to talk to you guys today. This initial presentation is a review of grape phenolics. I was asked to provide a presentation on phenolics. A lot of the audience is not familiar with this group of compounds or is new to the whole game. So I'm going to spend this first part of the session talking about grape phenolics and why they're so important to grapes and wine, obviously. So as a brief outline, I'm going to start by talking about the importance of phenolic compounds. Then I'll talk a little bit about general wine phenolic composition. And from that, you should have an idea, okay, these compounds are pretty important. We'll talk about localization in the grape berry. Obviously, as a winemaker, you're very aware that how you soak a grape and how you press a grape and so on, it has a critical impact on the ultimate composition of wine. And a lot of that traces right back to the localization of these compounds in the grape berry. So we'll talk about that a little bit. I'll talk about the specific compound classes. So the phenolics tend to be classified into different groups, and we'll spend some time talking about that. Analytical overview. I think one of the important things that I want to get out and message-wise to this audience is that they're not that difficult to analyze from a quality compound perspective. There's some of the easiest compounds to analyze. And so I'll talk about some of the things that we might want to consider when looking at that. And then finally, I will spend some time talking about how these compounds develop in the vineyard and how we can manage them in the vineyard. Again, this is a very brief talk. It's meant more as an overview of these compounds and hopefully get you guys excited about phenolics. I know sometimes it can be a dull subject, but boy, are they exciting. So let's launch right into it. So why are phenolic compounds so important? Well, if you look at wine, you know, the way we normally assess a wine, we evaluate its visual aspects, aroma, flavor, taste, and certainly tactile contributors to overall quality. If you think about phenolic compounds and what they touch upon from a perception standpoint, they literally touch every one of them. So there's no question that phenolics are important in quality for no other reason. We perceive phenolics in every one of these areas. The second point that I'd like to make is that as winemakers, we want to start thinking about moving beyond what I call roughing in metrics. And by roughing in metrics, I mean measuring pH and TA and soluble solids, GAN, maybe malic acid, basic juice panel information. And one of the things that maybe all of you have realized, or many of you have realized, is that you can have numbers that are hitting the target with regard to pH, TA, and soluble solids and such. But the problem is your grape quality and wine quality is just not where it needs to be. And at that point in time, you start to think about, all right, what else can I look at? And that brings up this third point, and that is of all these compounds that are relevant from a wine quality standpoint, phenolics are the highest concentration. So they're pretty easy to measure. A lot of times you can very much assess them with our visual aspects. And so that makes it easy to use phenolics as an initial launch point for measuring quality compounds beyond the simple roughing in material. The other point is, for many of you, if you're thinking about maybe adding instrumentation to your wine lab, or you have a wine lab with existing instrumentation, the buy-in price to measure phenolics is considerably lower than flavor and aroma compounds. So it's just easier in a typical wine lab to be able to do that. Finally, phenolic compounds are often indirectly associated with grape aroma and flavor compounds. So if you think about wines that have green characteristics or red or dark fruit characteristics, it can be difficult to really understand the aroma chemistry around and the flavor chemistry around these aspects without spending quite a bit of money. And oftentimes, how you manage flavor in the vineyard is similar to how you might manage phenolics. And so phenolics is almost an easy way to say, all right, I'm going to optimize phenolics. And a lot of times flavor development comes along for the ride. And I'll talk about this a little bit later. So let's introduce some of these general phenolic classes that I'm going to spend some more time on. I've got them broken out by important material and then perhaps what we might consider minor contributors. Starting with the important classes, there's compounds called hydroxycinnamic acids. These are present in all wines essentially, but they are critical to the color in white wines. The major hydroxycinnamic acid one finds in wine is caphtoric acid. And then on the flavonoid side, there's a whole group of compounds called flavonoids. Anthocyanins are something that probably many of you have heard of. They're responsible for the red color of red wine. And the major anthocyanin that one might find in most wines is malvidin-3-glucoside. Proanthocyanidins is another class of compounds. Many of you would think of them as tannins, and those impart astringency to red wines. Then we have our flavin-3-ol monomers, or catechins, which are classified as being bitter. And so here's some examples: catechin and epicatechin, which are flavin-3-ol monomers. And then finally, flavonols, potential precipitate formation. These are if you've got a, say, for example, Sangiovese or such, and it's throwing precipitate, oftentimes that can be due to flavonols. The reason we're kind of interested in flavonols, you don't perceive them typically directly, but they can often be important marker compounds for fruit exposure. So if you've got fruit that's shaded, your flavonol concentration in your wines tends to be quite low. So it's a bit of a barometer for how much exposure your fruit is being exposed to. The major one in most wines is quercetin. Then we've got minor contributors, hydroxybenzoic acids, as well as volatile phenols. I'm not going to talk about volatile phenols today or hydroxybenzoic acids, but obviously volatile phenols are becoming critically important today, primarily because of smoke taint. These are aromatic compounds. If you've got a wine that has got smoke taint, ashtray characteristics, the reason it is the compounds that you're perceiving are phenolic compounds. Britannomyces, if you've got a bread infection, those are phenolic compounds. I don't have time. That's a whole new talk to talk about. We don't not going to look at that too much. The other thing are oak phenolics. If you're aging wines in oak cooperage, those can impart some phenolics to wine. Typically, they're much less than 10% of the total phenolic pool in a wine, and that's assuming it's a massively extracted red wine that's aged in 200% new wood. You still don't get a lot of phenolics that are derived from oak. Some people will add exogenous tannins or wood tannins to a wine. Those, again, are typically in lower concentrations. This talk is very much going to focus on grape-based phenolics. And because of the lack of time, I'm going to kind of focus on the compounds in this group here. These are the major ones that we think about in wine. Finally, I want to introduce the phenolic structure. Many of you are not familiar with chemistry. I want to introduce these. I'm going to show some structures. Phenolics are pretty easy. They're defined by this six-membered ring here, which is called a benzene ring or an aromatic ring. And then you've got this OH group that's attached to it. So any compound that has this type of structure, where an aromatic ring and OH group, is called a phenolic. This is the simplest phenolic. This is actually a compound called phenol. So as you see these structures as we go forward, you'll see that they're all phenolics. Here's another example of a phenolic compound, gallic acid. So localization in the grape berry. For these important compounds, it's pretty straightforward. Anthocyanins for most internationally important grape varieties are restricted to the skin tissue. Some Teinturier varieties, Alicante Boucher, are pigmented in the pulp, but we very much think of anthocyanins as a skin-derived compound class. Flavonols are also skin-derived. Hydroxycinnamic acids are in the juice. All wines are going to have hydroxycinnamic acids just because the bulk of wine is pulp derived. And then finally we have tannins. These are located in the skin, the seed, and the stem tissue. It's important to remember that a skin tannin is not the same as a seed tannin, is not the same as a stem tannin. Compositionally, they tend to vary. And then secondly, some of the characteristics that come with those tannins are different depending on where they're sourced from. So for example, skin tannins, those are going to have color associated with it. Seed tannins, and I'll talk about this more, are also going to have potential bitterness associated with it. And then the stem tannins, we tend to think of stem tannins as providing aroma and flavor and some spice characteristics, but certainly lignified stem tissue. So with the stem tannin, you're going to get some aroma and flavor aspects associated with those tannins. So I'd like to spend some time looking at some of these specific compound classes. I'll start with the hydroxycinnamic acids. Here's a structure of a hydroxycinnamic acid. And here's that six-member ring we're talking about. Here's an OH attached to it. So this is a hydroxycinnamic acid called trans-caftaric acid. These are present in all wines. As I mentioned, they're pulp-derived, produced as tartaric acid esters in the grape berry. So this is a compound, if you just look at this portion of the molecule, it's caffeic acid. This is tartaric acid. So many of you, if you have to acidulate your wines, are adding tartaric acid to your wine. This is what you're adding right here, this component. And they're present as esters. This is just an ester here. The major hydroxycinnamic acid, as I mentioned, is trans-caftaric acid. What's interesting about hydroxycinnamic acids in general, and caftaric acid in particular, is if you look at this phenolic component here, there's an OH group here, and there's an OH group here. If you've got two OH groups that are adjacent to each other, it makes this compound very susceptible to oxidation. And for wine, that's a fantastic thing because wine has a built-in antioxidant system. And it's because of this. And as I show you some structures going forward, you'll see that there's a ton of these OH systems in wine that are designed to do that. In this case, the color of white wine is specifically a result of the oxidation of this sort of functional group. So that yellowing that you see in your wine, the straw colors and such, it's oxidation. And so as that pulp gets oxidized through that winemaking process, our white wines are going to become increasingly yellow. And you see that as you look at an aged white wine versus a young white wine. It's because of that component there. Very important. Wines can deal with oxygen periodically because of this type of a thing. For hydroxycinnamic acid specifically, one of the things that we think of as trying to manage composition in the vineyard and manage wine production practices in white wine is looking for a specific compound, this grape reaction product. This is clearly an absolute oxidation product of white wine. And if you got over-oxidized wine and you suspect it may have happened at crush or such, it's easy to analyze a compound like this to get confirmation that yes, that this wine was assaulted. It got too much oxygen exposure early in its use. Mentioned this involved in white color. Analytically, if we wanted to analyze for hydroxycinnamic acids, if you really wanted to analyze for GRP, for most wineries, it's beyond the instrumentation capabilities of a winery. We would submit this to a wine lab, and there's wine labs that are in most of the wine regions of the world that have HPLC, that's this high performance liquid chromatography. And you can submit a sample to them and ask for a hydroxycinnamic acid panel, and they can typically provide that. Really straightforward. Indirectly, you can measure this using a UV-Vis spectrophotometer. And this is where wineries start to get interested in this stuff, is that if you can use a UV spec, then sometimes you can at least get some preliminary information on these compounds. The second compound class is catechins. Here we see the structure is getting a little bit more complicated, but straightforward. You've got these OH groups, and here's this OH groups that are adjacent to each other, very susceptible to oxidation. That's a good thing. It's the antioxidant system in wines. Some other names that we think of when we think of catechins are these flavanthriol monomers, as I mentioned, some specific compounds, catechin and epicatechin. These are almost exclusively seed-derived. By the time you harvest grapes, most of the catechins that you find in a wine are going to be result from the seed. Some people look at the ratio of catechin to tannin concentration, and this can provide some rough assessment of how much seed extraction you have. And clearly, if you're picking up bitterness in your wine, it's due to catechins. These are increasing bitterness in wines. Higher concentrations are clearly bitterness. If you fine a wine, you remove tannin from the wine, the proportion of catechin to tannin increases. And you often see this unmasking of catechins. And so some of you may have seen from a protein fining perspective that you get more bitterness when you fine a wine. And that's a transient effect, but it's due to these catechins. The concentration declines with maturity in terms of extractable catechins, and very much extractability of catechins roughly follows the browning of seed coats. And so if you've got a lot of green in your seed coats, those catechins are going to be more extractable than they would be if they were brown, all things being equal. Analytically, if we wanted to analyze catechins, we would use high-performance liquid chromatography. Another group of molecules, anthocyanins. This is a three-ring structure. You can see that it's similar to catechin. The difference is in this region right here. And what this does, if you look at the differences here in this structure, this gives rise to the red color that we see in red wine. So anthocyanins have this component involved. They are responsible for the initial color of red wine. The long-term color stability of red wine depends on the reaction with other compounds, specifically tannins. And so if I were to analyze, say, a 2-year-old red wine, that initial red color has been transformed. And you don't see much of stuff like this. These compounds have reacted further to form color-stable components. Higher concentrations of anthocyanins are associated with darker red wines. Pretty obvious. The thing that's interesting about anthocyanins is that they have several equilibrium forms, and I'll mention that in a minute. pH sensitive, there's colored and non-colored components. The red form is not the major component. Analytically, HPLC can be used, but you're submitting samples for analysis. And then indirectly, you can use UV-vis absorbance. And certainly your visual perception of the wine is a very important analytical tool that we use. And obviously, it's easy to assess a red wine for its red color. So here's the anthocyanins again. When I said equilibrium forms, these are all anthocyanins, all of these. And they all are in equilibrium. And this, you see these forward arrows and backward arrows. This structure, which is the same as this structure, is going back and forth. The structure is being transformed. So there's some of this and some of this, and the ratio of this to this is dependent upon a lot of different things. So here's our colored form. So this is the same structure as this. And for example, if you add potassium metabisulfite to a red wine, you see this bleaching effect. And this is what is happening. You're adding potassium metabisulfite, and this bisulfite component is adding to the anthocyanin, and it makes it colorless. And so that's the phenomenon of bleaching. What I would like to direct you to is this equilibrium right here. So this is going back and forth. This is our red form. This is our colorless form. And so these are the two predominant species in any wine, these two guys, so colorless, colored. And if we look at those structures again, red form, colorless form, and we look at the pH of our wine on the x-axis here, and these are the equilibrium forms that are present as a function of pH. This gray bar here is wine pH, the range of wine pH from 3 to 4. And what we see here, the red form and the colorless form, is that at wine pH, the amount of colored material is actually quite small. And the colorless form, pretty high. So the reason I bring this up is, as a winemaker, one of the things that you want to be able to do is stabilize the red color in your red wines as quickly as possible. There's more of an opportunity to stabilize this structure if the product becomes colored. And so there's a lot of time that's being spent in the research world to understand structures that are products of this molecule that ultimately are red in color, because there's a great opportunity to increase our wine's color stability by doing those modifications. The final class of molecules I'm going to talk about are the tannins. This is a three-ring structure, and the thing that differentiates tannins from these other molecules is that you can stitch these three-ring components together. And they can be anywhere, from 2 of these units up to 30, 40, 50 plus units. And so large molecular weight range. Other names that have historically been associated with tannins are proanthocyanidins, procyanidins, prodelphinidins, condensed tannins, leucoanthocyanidins. This class of tannins is a different chemical structure than oak tannins or other wood tannins, which are in a class of compounds called hydrolyzable tannins. These tannins are responsible for the astringency in red wine. They're found primarily in the skin, seed, and stem tissues, as I mentioned. The concentration of tannin in a wine is related to perceived astringency. So if you were to measure the concentration in a bunch of red wines of tannin and then assess their astringency, there's a rough relationship, probably correlation coefficients I've seen of 0.8 or so. Large molecular weight range, as I mentioned. The lowest molecular weight range, the lowest molecular weight tannins, this is the dimer, and this is the smallest tannins get. This would be classified as a bitter tannin. Much larger, they become predominantly astringent. For red wine color stability, tannin presence is essentially considered to be critical for color stability. Contrast that with, say, like a rosé wine, where you have very little astringency in that. You know that the red color is pretty transient. Those wines will transform from pink to salmon to orange reasonably quick, and that's because those anthocyanins are not being stabilized, and that's because you haven't extracted tannin into those systems. So the perception of tannin, the thing that makes them magical in my mind is that their perception is dependent upon other components. And so when you talk about green tannins and hard tannins and soft tannins, a lot of the perception that we see there, the qualifying descriptors, are related to other things in wine that change how we perceive those tannins. Analytically, if you were to want tannin analysis, high performance liquid chromatography can be utilized, and certainly in-house wineries for those who have UV vis absorption spectrophotometry, you can do that as well. Here's a little slide that has identified some of the things that we think of as impacting our perception of tannins. Here we have the tannin concentration and the composition of the tannin over here. Here we have our perception of that tannin. It's important to realize that our perception of the tannin has to be seen through a bunch of other things that are in red wine, right? So color, ethanol, polysaccharides, organic acids, glycerol, residual sugar, nanoproteins. These are things that we know have an impact on how we perceive tannin in wine. Interestingly, from a cognitive perspective, aroma compounds can impact how we judge astringency in a wine. So briefly on an analytical side, I kind of roughed it out that if you have a winery and you're really interested in getting some quality compound information, phenolics are the place to start. It's the lowest, and it's the cheapest buy-in from an instrumentation standpoint. The instruments tend to be in the neighborhood of $10,000. You can justify, a partial head count to collect that analytical information. It's pretty easy and straightforward to use UV vis spectrophotometers. Oftentimes, that's what you initially will go after because that spectrophotometer can be used for other things. When you apply that spectrophotometer to phenolics, I tend to think of it as these are the big areas that people tend to be interested in: red wine color and red wine mouthfeel. So you can measure anthocyanins by just simply measuring the absorbance of your system at 520 nanometers. But as I've mentioned earlier, it's very important to capture additional information if you are to truly understand the role that anthocyanins play in wine. I mentioned pH, so you obviously need to get that information. You need to get tannin concentration because that is important to the stabilization of color. And then finally, if you're looking at grape analysis, it's not enough to simply produce color or anthocyanins in grapes. The question then becomes, how easy is it to get that color out? In a lot of analytical labs that you submit grape berry samples to, they've optimized extractability for their specific analyses. And that extractability number becomes important because it's a barometer of how easy it's going to be to get that color out of the berry during fermentation and maceration. The same thing with red wine mouthfeel. We know that astringency is critical to mouthfeel, but it's not enough to just simply get tannin concentration. There are other things that you want to consider. Anthocyanin concentration, I mentioned extractability. It's even more critical with tannins than it is for color with regard to extractability. Acidity, ethanol, residual sugar, and polysaccharides. Berry development. Here's flowering over here, and here's harvest over here. This green line here represents berry volume as a function of time. Tannins are produced prior to veraison, and anthocyanins are produced post-veraison, obviously. Tannin maturation is this mystical thing that we look at to try to understand how tannins that are produced pre-veraison transform during fruit ripening. There's a lot of work that's been going on in this area. I know Dr. Karen Binden, who's going to be up next, has spent a lot of time talking about this. I'm not sure she'll spend any time talking about it today, but certainly I would recommend that you look at some of her work. If we look at the environment and how environment impacts perception, or how the environment impacts composition of the grape berries, we know from a critical control point that if we want to start to manage phenolics, the first place we want to play with them is in the vineyard. And here's an example of a review article by Stefano Poni looking at photosynthetically active radiation and how that photosynthetically active radiation impacts grape composition. So low light, high light, and then here's some different chemistry that's going on in the grape berry. You know, the cyanins, you can see this red line increase with exposure up to a point, and then they level off. And then at some point, they start to degrade, likely due to anthocyanin degradation. Skin tannin is this black line, skin proanthocyanidins, again, increasing light exposure, increasing composition, but there's other components that you want to be thinking about. Methoxypyrazines is this indirect measurement where if we're optimizing phenolics with exposure, methoxypyrazines, which give green character, bell pepper, green bean characters to wine, you can see that with exposure they decline. Moreover, darker fruit flavors increase. And so the reason I put this up is that it's the first place that we want to start playing with phenolics in the vineyard. It's a complex picture. Temperature has been shown to have an effect. Obviously, I think water stress is definitely having an effect, whether it's a pre-veraison water stress or a post-veraison water stress. You can see that that's going to have ultimate compositional impacts on what you see in the berries over time. Final slide from my standpoint is thinking about allocation grade of grapes and how phenolics impact the quality of fruit. I hope I've shown you in my presentation that these are compounds that can be managed in the vineyard. We know that they can obviously be managed in the winery. The vineyards are clearly the first place a lot of people look to try to optimize phenolic quality. This is a study that I did when I was in Australia, and it looked at working with Hardy's Wine Company, looking at how phenolic composition in wine changed with winemaker perception of quality. And at the highest grades of quality, the winemakers definitely found that phenolics were high as a rule, but there are other things that impacted what they ultimately ascribed a price point to. On the other end of the spectrum, a decreasing quality, tend to be lower phenolics, and again, winemaker perception of quality tended to be around other things besides the phenolics. But there's this whole range in here where winemakers said, all right, this is an increasing quality wine. I can get more price on this wine. And so if you can manage your vineyard to grapes with this sort of thing, you're going to get more a higher price on your wine. And it's certainly because of its a higher quality. So things like tannin concentration, tannin molecular weight, we can now say that that's because it's purely stringent as opposed to bitterness. Epigallocatechin, this is a marker compound for skin tannin extraction. So if you can get more skin tannin into your wine, winemakers tend to perceive it as a higher quality astringency. Pigmented polymer, and this is what we think of as stable red color, is higher. But it's not just that it's a stable color. I think the perception of the astringency of a pigmented tannin is different than that of an unpigmented tannin. And then wine color density. So this is the vineyard effects of phenolic management. No question that vineyard plays a role in ultimate quality. These are compounds that you can manage and measure in the winery. So it's a great place to start, I think, in terms of optimizing your wine quality is in the vineyard. And we all know that. So with that, I'm going to turn this presentation over to Dr. Karen Bindon, who's going to spend some time talking about some of the her latest findings and her group's latest findings in the area of maceration. Dr. Karen Bindon came to the Australian Wine Research Institute by way of South Africa. She got her bachelor's degree and master's degree there at University of Stellenbosch, where she did some work on plant and viticulture science. And then in 2008, she moved to the Australian Wine Research Institute, where she has been there for the last, 13 years. Her current position at the Australian Wine Research Institute is research manager for chemistry. And Dr. Karen Bindon is considered to be a world authority in the area of grape and wine phenolics. I think we're extremely fortunate to have her. And with that, I'm going to turn it over to Karen.
Yeah, good day, everyone from deep down under. It's really great to be here with you today. And I'd just like to thank the the actual organizers of the Oregon Wine Symposium for inviting me back. In a different time, it would obviously be great to see you in person and to be able to chat with you, but I'm really grateful for the opportunity to share some of my work with you today. So I'm really addressing here the overall topic that's been put forward by the organizers, and that is partly continuing on from what Jim Kennedy has already shared, but to really review grape phenolics and then to move from that into looking more at the maceration techniques. So moving on, I just don't want to repeat anything that Jim Kennedy has already shared, but just to address the really important classes of phenolics in red wine. They're the flavonols, and these are the colorless group of compounds that originate mainly from the skin. These are photoprotective in the grape and can actually serve as co-pigments in the wine to enhance wine color. The anthocyanins, obviously the really important class of compounds that contribute to color. And what's also important is that these tend to form stable reaction products, which have a much stronger color at wine pH than the anthocyanins in their native form. So it's some of these reactions that we'll talk a bit about today and how these relate to non-bleachable pigments in wine. Another really important class of compounds are the flavonthreols, and then these can be in their monomeric form. But what's really important is that through the grape development process, these individual subunits of monomeric flavonthreols polymerize to form tannins. And it's these reactions with anthocyanin, of tannins with anthocyanin, that can largely contribute to the formation of non-bleachable stable pigments in wine. And so what I'm really going to be honing in on today is the measurement of anthocyanins and tannins in grapes and wines, and how this can really be applied in real terms. What we really need to understand at the outset is the sweet spot. So where do we want to be in the winery for tannin and color? Which was done quite a while ago now on Shiraz, was actually to put wines to a group of consumers and to see what they really wanted in terms of the actual tannins in their wines. So this just shows you a graph of the astringency drying intensity of those specific wines related to the sensory properties, and then the tannin concentrations of those respective wines, which are just applied there on that curve, just next to those individual yellow markers. On the other axis there is the mean liking score. And what you can see there is that there's almost a peak in that curve, which we would call the tannin sweet spot. And that really is an ideal concentration between 1.3 and 1.9 grams per litre, under which and over which the liking actually dropped away. So what we really want to understand is with maceration, we don't want to overshoot, but we want to get the maximum potential out of our grapes. Looking back at tannins, and Jim has already covered off on a lot of this work, is to understand that they have different properties and also different sizes. So I've mentioned that the polymerization reactions from the individual flavonthreols occur during grape development. And what we see here is that those extend the tannin polymer to form a certain length. And what we call that is the mean degree of polymerization. It really refers to the average. That relates to the molecular size of the tannin. And what we know in general is that skin tannins tend to be larger than sea tannins. And ultimately, we also understand from some work done on sensory properties of tannins that the lower NDP or smaller sea tannins tend to be more bitter, and that the larger skin tannins tend to contribute to a development of astringency. We also know that more tannin also means more astringency, like you saw in that previous graph. So when we talk about tannins, we want to maximize the amount of tannin in the wine, but we also want to be very aware of the type of tannins that we're drawing out of the grapes during the maceration process. I'll relate back to some of this as we go along. Another important question around where we want to be in terms of tannin measures is to also understand quality. So wine quality is often something that is very specific to a region, for example, a specific grape variety, or the preferred wine style of a given producer. So when it comes to quality, there is no sweeping definition, and through a number of studies which have been done over multiple seasons with different producers, different varieties, we know that phenolics measures are very relevant, but it is important to note that that will vary very, very dependent on the producer. Jim already shared some slides in his talk, which showed a study which was done on Shiraz with Hardy's wines, showing a very similar trend to what I'm showing you here. This was done with just a single producer using a single region. And this just shows you wine tannin, wine color density, and non-bleachable pigments, all showing that very clear downward trend, moving into the quality grades of those respective wines. So we can see here again a little reflection of that sweet spot there, showing you here with wine tannin, for example, that between that 1 gram to 1.5 gram per litre, you're starting to see that increase in quality. I think what Jim showed is it tends to be a bit more of a different kind of curve. So you're not necessarily seeing a linear type of effect, but it does show you the relevance of these measures to an individual producer's quality. Moving on from this into understanding maceration. We need to understand how phenolics are extracted from the grape into the wine. So over a number of years, also in collaboration with Jim Kennedy, who's already shared today, we did some work to understand extractability. So here we have a theoretical tannin in the grape cell. And as the grapes are crushed, that tannin will be extracted into the wine must. But there's interactions which occur here with, for example, the cell walls of the grape cell itself, and also, in this case, the solution of the must into which the pulp cell walls will be suspended, together with proteins and polysaccharides extracted from those cell walls. So there's various points here at which the tannin can actually bind and be removed by interactions. So what we see is there's also interactions with grapes, yeast cell walls, and much of that tannin and associated color will be removed from the wine solution. So ultimately, what one ends up within the wine soluble tannin and also associated color, is a reflection of multiple interactions which occur through the extraction process. So when we talk about maceration, what we're wanting to do is uncouple some of these interactions and or increase the process of extraction by changing the dynamics during these associations. A second point at which interactions can occur is that there's soluble polysaccharides, which eventuate through the extraction and maceration process. What we generally see here is that the tannin will form stable complexes with these. They do not necessarily precipitate out in large quantities. But what we now also know through work done on hybrid grape varieties, which obviously predominate in the US, is that some varieties can actually produce large quantities of grape proteins. And these proteins can form unstable complexes with tannins and precipitate out, further decreasing the actual concentration of tannin in the wine. So ultimately, what we want to do is really work with the system to maximize, but also, if need be, also reduce the amount that is extracted. Another key thing to understand is the role of anthocyanin in tannin extraction. So what we did also a number of years ago now is to actually work with a mutant Cabernet variety, which had exactly the same tannin concentration and composition of a normal Cabernet variety, but it did not produce color. What we could see there is that although they had very similar skin tannin content and composition, if you actually looked at the extractability, the tannin extractability was 52%. So 52% was extractable from the standard Cabernet, but compared to the mutant, the extractable tannin was only 12%. What we then did was to take anthocyanin and add it back to the system, and adding anthocyanin concentrations to the levels which would normally be present in grapes actually facilitated extraction of tannin from that mutant Cabernet. And so we saw that it approached 48%, so very similar to what we saw with the standard Cabernet. So very simplistically here, we can conclude that color enhances skin tannin extraction. What we don't know at this stage is why that is. And so hopefully future research will start to unravel that story. A further point during this process where we can see losses of tannin and also associated color is because of the instability of the pigments which form from the reaction of tannin and anthocyanin. So here we see, for example, a small tannin and a larger tannin, either from skin or from seed. And following the reaction of acetaldehyde and anthocyanin, so this is just not normal direct linkages between these two molecules, but when it's facilitated by acetaldehyde in wine, what we see is that the smaller tannins form much more stable complexes and remain in pigmented form in the wine. And what we see is that when they're larger, they actually form aggregates and precipitate out of the wine. So these little videos here just show you the actual nanoparticles in these different solutions, showing you here that, for example, with larger tannins, they form aggregates which actually are unstable and precipitate out. So this can be facilitated by acetaldehyde formed either by yeast or due to the presence of oxygen in the wines. But what we also know is that despite the precipitation which occurs, the compounds which form, so the non-bleachable pigments, tend to actually be very highly pigmented. So one wants to optimize acetaldehyde to an extent, but not to create an unstable situation where we actually lose tannin and color from the wine. So looking at maceration again, we tend to see that maceration techniques tend to be phenolics focused. So one's aiming to actually optimize color and or tannin extraction. These can be used to accelerate the time in tank or to selectively extract either skin or seed tannins. And also, for example, can also impact on overall style. So for example, carbonic maceration would really be a stylistic choice by the winemaker. What I'm going to be honing in on today is to understand why one wants to use a maceration strategy. So the important point here is to understand the starting point, the grape phenolic concentration, the extractability of those grape phenolics, and also the ripeness of the grape. Ultimately, one wants to weigh up the cost benefit of using a maceration technique. For example, extended maceration, spending more time in tank, is that really going to realize gains from a quality standpoint? Ultimately, one also might be aiming for a targeted wine style. And that points back again to individual producers and wineries and what they aim to get out in terms of their particular style and quality. Ultimately, and there's another talk which I'll direct you to, which I don't have time to cover off on today, one wants to be sure that when one chooses maceration that other quality targets, for example, aroma and flavor, track with phenolics. So it's important here to understand that through the maceration technique chosen, certain phenolics may tend to dominate the wine texture. And one wants to avoid that and have to actually use fining agents to remove what is extracted. So what we want to understand today is how can the winemaker dial color and tannin up and down, and how can maceration techniques be used in this way? What is important here, and coming back to the grape story, is the starting point. One needs to understand all of those interactions which take place and to understand the extractability of those phenolics. So over a number of years and through all the work which we did to understand the interactions with tannin and cell walls during the grape maceration process, we developed an extractable tannin and color assay at AWRI. And I'll just point you here to AWRI's Wine Cloud. This is not really intended to be a marketing session, but just to point you there to also more information, and those links will be provided by the organizers of this session. What we found with this extractability assay is that we found a strong relationship from grape to wine. So here you see grape extractable tannin on this axis, and the actual wine tannin on this axis. These individual colors will show you the different regions which were looked at. And what we saw here is a very strong relationship between extractable grape tannin and final wine tannin. One sweet spot would probably be sitting somewhere here in the middle. We also saw that for the anthocyanins here, that this is extractable anthocyanin and wine anthocyanin. In this case, these were very young wines, so we weren't really looking at non-bleachable pigments in this stage. But here we could see again a very strong relationship, also very, very clearly defined by region. What's important here is to understand that these differences were driven mainly by skin tannin extraction. So what this assay does is really to look at standard extraction of skin tannin, which would occur through this 6-day maceration process on skins. And really that period on skins is driven by skin tannin extraction largely. Seed tannin extraction tends to take place later during the maceration process. So what we really saw here is that with these higher tannin concentrations, that was also related to high molecular mass, or MDP, and this was driven primarily by skin tannin. We also saw a very strong relationship here, as you can see from this axis, with anthocyanin concentration. That points to the fact that it's the individual reactions of these two different groups of compounds, with anthocyanin facilitating extraction of tannin in this case as well. Moving on also to look at perhaps the more traditional measures, we also looked at the total tannin and anthocyanin assay. This is from homogeneous extracts. And what you can see here is that when one looked individually, this is Cabernet here and Shiraz, that we saw a fairly good relationship here between total tannin and wine tannin. But this wasn't a good relationship when one looked at it over the two varieties together. So there was no relationship here not a very good R-squared over the both varieties, but a better relationship for homogeneous anthocyanin and wine anthocyanin here. So these measures are still meaningful. They just need to be used with knowledge that it has to be applied to individual varieties. Again, you can find more information on this at the AWRI's Wine Cloud. So what does this mean from a wine composition perspective? So one wants to understand how to use these measures. And so this just shows you a little correlation table, looking at really the more strong correlations here of how these measures relate to actual wine composition. So here we saw that the extractable tannin and extractable anthocyanin measures correlated fairly well with most wine measures. So wine color, but also non-bleachable pigments. But what we saw is that when we looked at the total measures, total tannin and total anthocyanin, there was a less strong relationship with all of these measures. So only really total anthocyanin related quite well to the development of wine color. Just want to point out here that, for example, we looked at the ratios between different classes of compounds. So looking at the anthocyanin to tannin ratio in extractable extracts, total extracts from grape, and also the wine. And we didn't find in this case that that ratio related to any of the individual wine measures, so I haven't shown it here. And we also didn't find that these ratios related well to each other. So this wasn't something that we explored any further. How one actually would use these measures is to understand where one is in terms of vineyard phenolic ripeness. So this just shows you work which was done in McLaren Vale Cabernet from a PhD student who was working with our group. And we've done this over multiple vineyards and seasons and found that this consistently occurs through ripening. And what we could see here is that as that extractable tannin changed over ripening, ripeness one saw a strong relationship with final wine tannin. In this case here, moving from a very early harvest at only 500 milligrams per litre, right through to 2 grams per litre at the later harvest. What one could see here is that when one diluted, for example, this very late harvest back, we saw that for Cabernet, for example, this did not change the total tannin concentration or color. We saw a loss of color when Shiraz was diluted, for example. What we see here is that this tends to be a trend in skin tannin accumulation. So Jim alluded to this in his talk where he showed that the trends tend to be seed tannin decreasing and skin tannin increasing through ripeness. But what we see here is this is a combination of skin tannin accumulation, but also a reduction in berry size. So it's an effect of both of these, which result in that wine tannin concentration increasing with ripeness. Another way one can use this measure is really to look at vineyard variability. So for example, some work which we did more so in the development of these particular assays was to look at a vineyard which was quite variable in terms of vine vigor, but also soil depth, in this case, 0.75 versus 1.5 meters. And what we saw here is that when the soil depth was compared, we saw a drop in wine tannin as the soil depth was compared. And then a section of this vineyard was over-irrigated and we saw an even further decrease in tannin. And this was very, very closely coupled with that non-bleachable pigment and color density trend. So I have not shown you that data here. What we can see here is that that was really, again, driven by skin tannin, decreasing with very little change in seed tannin. And again here, that extractability assay of the whole berry showed you that same trend here. So this is useful also to understand whether one needs to harvest differentially within a vineyard to understand those impacts. And we've explored this over multiple seasons, and I don't have time to show all of that data today, but we do see that these measures can relate very, very strongly to the vineyard variability. So moving into where we want to use these measures, what one wants to understand is we know where we start, but how far do we really want to push that system using maceration techniques? So I've mentioned that maceration techniques can be used for various reasons. But what I'm going to really drill down with today is so we know our starting point, but how far do we push the system by applying maceration techniques? So over a number of years, we've applied these techniques that I've mentioned over multiple trials. And we've asked the questions, what is the effect on wine tannin and color? And what is the extent of that effect? So for example, one can apply pixylitic enzymes, use different yeast strains, which actually have enzyme activity, which can facilitate maceration. One can apply extended maceration or saignée. Tannin addition is an important consideration, also as it relates to what I showed you with respect to, for example, reactions which occur with anthocyanin and acetaldehyde, and that actually can lead to a drop of tannin ultimately in the wine. So if one's throwing tannin in, does it actually remain in the wine and produce the effect that we desire? Fermentation temperature is an important consideration, as is, for example, using whole bunches or whole berries. And there's also a new technique called the Della-Toffler maceration accelerator, which can chop up the berries further than what one would get through a standard crush. And this facilitates maceration or extraction from those cut edges of the skins. But actually, what that can allow for is a reduced time in tank. So what I've done is actually look at all the different experiments which were done over multiple years and of different varieties. And I've actually looked at a scale here, the percentage change from the standard maceration treatment, which would be normally between 6 to 8 days on skins. And what I've done here is to look just at color and tannin. And I'm going to work through these different trials with you to really understand if I'm going to apply something, how far is that system going to be pushed? Before I move into this, I just want to direct you here to a link to our AWRI YouTube channel. And I've asked the organizers to provide this link for you. And this just will give you a much deeper overview of these different trials to understand, as I mentioned before, how this relates to also sensory properties of the wines, other flavor and aroma aspects which can be achieved using maceration techniques. But because I've been asked today to talk specifically about just phenolics measures, I don't have time to go into that today. So I'd like to just direct you to this talk so that you have the opportunity to explore this further in your own time. So starting here, looking at the Della-Toffler Maceration Accelerator, or DTMA. It was initially started to try and look at Pinot Noir, which often can have low tannin and color, to see if one could increase the extraction in Pinot Noir. What one can see there is that we were looking at increases in tannin, for example, of close to 600%. So that would be talking from a normal Pinot Noir, which might have 300 milligrams per liter of tannin, to 3 grams per liter of tannin. It was an exceptionally large effect. What we saw here is that those wines tended to be quite astringent, and so a subtler technique was perhaps useful for Pinot Noir. What we've also done now is to move on from that. You can see here that we've worked on Shiraz as well. And we found a much smaller effect here on Shiraz, so about a 23% increase in tannin here. And no change really in color. What we're finding for the Shiraz wines, there tends to be a much subtler effect with a more chalky and mouth coating texture. So we're seeing not real changes in tannin composition. So we're not breaking up the seeds and extracting tannin from the seeds. We're really just facilitating skin tannin extraction, or what we would see out of a standard maceration. But we are seeing that there is some textural differences which are achieved by this. Small differences in color. For Pinot Noir, quite a large increase in color, but not to the same extent that we would see for tannin. So this is perhaps a bigger investment in the winery. So other things that one can look at, for example, are fermentation temperature. So here, just looking at Cabernet and Shiraz, simply looking at a change in fermentation temperature from 21 degrees to closer to 30 degrees. What we could see there is that there was actually substantial increases in both tannin and in color. So looking here really at the temperature increase, fermentation temperature increase, what we would see is about 100% increase in tannin here for Shiraz, and 62% increase for Cabernet, with increases in color about 20%. Very, very simple technique, not something which one would normally consider, trying to retain perhaps certain aroma and flavor profile of the wine. But in terms of phenolics, really quite a substantial change. Moving to the more extreme measures here, looking at microwave and flash détente. Here, looking at Pinot Noir, very, very large increase in tannin, smaller increase in color, but still substantial. And for Shiraz, also not as great an effect, but nevertheless a substantial increase in tannin and also color. For the Marquette here, well, that's a hybrid variety. We analysed some samples from our collaborators at Iowa State University, seeing here for that Marquette a very substantial increase in tannin, also colour in this case. These are obviously, again, high investment techniques. So there are perhaps simpler things which one can do in the winery, which also produces an effect. And work was also done looking at pressings addition. So the concept here is that one can simply just take pressings from, for example, Pinot Noir sparkling base or Chardonnay, store those pressings and then add them back to a ferment. What we saw here is that for Pinot Noir, very, very strong effect here of increasing tannin. Again, not quite as far as we saw for the DTMA, but still substantial enough to produce a change in the texture of those wines. It wasn't altogether unpleasant. But what we found for Shiraz here was that we got the increase in tannin, but those pressings actually stripped out the color. So perhaps useful for something like Pinot Noir, which has lower color. And what we saw here is for Pinot Noir, it actually increased the color of those wines. So in this case, we're talking here at about a 20% addition of pressings, and a very, very simple and nonetheless useful approach which one can use for Pinot Noir. I've changed the size of this axis here because that was obviously inflated by that very, very large change in the DTMA. But moving into looking at whole bunches, we did some work on Shiraz and Pinot Noir, working from 25% whole bunch through to 100% whole bunches. And we found for Pinot Noir that there was actually no effect on phenolics. We saw some improvement in the hue of the wine, slightly redder with whole bunch, but really no effect on phenolics at all. What we found for Shiraz is that even a 25% addition of whole bunches increased tannin extraction from the stems. And so there was about a 75% increase in tannin, subtle increase in color. And when we moved to whole bunch completely, we get 125% increase here in tannin. Here, it's very important to note that that main extraction is coming from the stems. And what we find is that the stem tannins tend to be more gallolated and slightly larger than the skin tannins. So what we do see here is a very strong increase in astringency. So it's definitely a technique that one can use to increase tannin, but one needs to also be aware of that astringency effect and also green characters which are extracted from the skin. So there's a lot of, from the stems. So there's a lot of methoxypyrazine there. So important study which was done from a phenolic standpoint, but again, something which one might want to apply with caution and not particularly useful for Pinot Noir as well in terms of what we found. So very, very simple tool for the winemaker and something which most people would apply, but not necessarily think of it in terms of phenolics. Yeast selection, very, very simply, for example, using strain RT212 for Pinot Noir, 2323 for Shiraz. What we saw here is substantial increases in tannin relative to an EC118 control. Also increases in color, and in this case with non-bleachable pigments. What we also found here is that there were very positive changes in the sensory properties and profiles of those wines, and that the type of tannins extracted were very similar to what one would extract in a normal ferment. So one was really just increasing the quantity of tannin, but not really markedly changing the composition. So very, very positive outcome, very, very simple tool for the winemaker. Here we also see that just using wild fermentation can increase tannin substantially. And there are also non-sac strains out there now which can produce these effects, although not altogether consistently. I could perhaps cover off on some of that during the question and answer sessions. So here, yeast, probably more important than one might have thought from a phenolic standpoint. Now, moving on to what one would call applying maceration enzymes, one could see here that a substantial increase in tannin, but not actually color, could be produced. And what we've also found with the work on enzymes that it's not necessarily always consistent. There's some typical batches of grapes which may not actually change with enzyme addition, and some which you can see is quite a substantial increase in tannin. Interestingly here, we're not seeing that strong change in color. So one can increase tannin extraction, but not necessarily change the color. And I'd also like to note here, coming back to those tannin properties, what we see here is that enzyme tends to extract larger and more aggressively astringent tannins, which may not necessarily produce a positive outcome on mouthfeel. So unlike, for example, the yeast producing very similar effects on tannin concentration, one was starting to extract much more aggressive tannins using enzyme. So useful, easy tool, must be used with caution. Extended maceration is interesting because obviously it means a lot more time in tank. And I think really here one is driving for more of those stylistic effects. We've done a lot of work on extended maceration. I'm just going to show you here some data from some work done on Cabernet and Shiraz, looking here at 20 days, also up to 60 days for Shiraz, for Cabernet. But here one can see that up to 50% increase in tannin concentration with extended maceration. And here that extraction is largely coming from seed tannin. Importantly though, one might associate those seed tannins with a much more bitter and aggressive astringency. What happens here is we do not see that. Large increases in tannin concentration, but they're much softer tannins overall. So ultimately, some of those reactions which may take place during that process may ultimately soften the reaction products of anthocyanin and tannin. Important to note here, though, is that there were losses in color through this process. This doesn't necessarily happen across the board, but for these larger scale trials, we saw that there were consistent decreases in color, increasing further as the extended maceration time increased. So here, probably something one would be aiming for a stylistic reason, not necessarily just for a phenolic management reason. So now probably one of my more interesting things to talk about is the tannin addition story. Now, obviously there's a lot of products on the market that are available. And what we found is that tannin addition can increase tannin concentration. It's marketed oftentimes as a color stabilizing tool. Now, harken back to just that earlier slide, which I showed you regarding the reaction products of anthocyanin and tannin. If one adds that during a fermentation where there's high levels of acetaldehyde formed during fermentation, the reaction products can lead to instability and precipitation, not retained in the wines. So these are perhaps some examples where we saw increased tannin, no change in color, but there's also some examples where we've seen that the tannin is added to what one would apply from a commercial standpoint, and there's no change in tannin concentration at all. So expensive if one wants to really produce phenolic outcomes. So understand these things when one makes those decisions. Then moving on to perhaps some of the more subtle techniques, so saignée and cold soak. Here, when we looked at saignée for Shiraz from between 8% and 17%, only when one moved to a 17% runoff did one see a very, very small increase in tannin and color. But this was lost, in fact, over the aging period. And so I think this is a cost-benefit scenario where one might be wanting to make a rosé from the juice. And from that perspective, it could be a useful or commercially viable scenario. But from a phenolic standpoint, perhaps not as beneficial as one might have expected. Simply using yeast could actually far better improve the phenolic portfolio of those wines. Again, here, cold soak, often used perhaps more for stylistic reasons. Generally, we find, and this is only a data from a few trials, no or a very subtle change in phenolics, often some decreases in color. So thanks everyone for walking through this with me, but I think it's important to understand globally, now that we've done a lot of work looking at these measures over a number of different years, different varieties and trials, to start to understand the quantum of where we are sitting in terms of maceration techniques. So again, just direct you to the talk, which will drill down into some of these in a bit more detail. But really, when one wants to understand the starting point, where we are at with the grape phenolic potential, and to understand where we want to be in terms of the winery. Do we really want to push it as far as a DTMA maceration for Pinot Noir, or do we simply just want to, for example, apply a wild ferment? So again, just to direct you to AWRI's Wine Cloud, it's not, again, not a marketing tactic, or maybe it is, but just to, again, direct you to some more information that's there. And just to highlight some take-home messages again. So understanding here that the extraction of phenolics from grape is influenced by multiple factors. And we can see there that there's large within vineyard variability, ripeness is very critical. And so one really needs to understand where one is in terms of phenolic extractability. So when we look at applying a maceration strategy, understand the initial grape phenolic potential. So we can actually do this via the wine cloud, and there has been some uptake of these techniques, for example, in California. And what we've got on the website is also some tools there to correct to Adams-Harbitson assays, which are more widely used in the US relative to our techniques, which tends to use the methylcellulose precipitation method. Again, probably a very important take-home message here is to understand the cost versus benefit of a selected maceration technique. Extended maceration means more time in tank. Are we aiming for a stylistic effect, or are we trying to soften the tannins? It needs to be weighed up against what one wants to achieve from a stylistic perspective and a quality perspective. On this note, simple tools, for example, like adjusting the yeast selection or the fermentation temperature, may have a greater positive impact on the phenolic profile than more intensive maceration strategies. And just to bring home again, for example, for the Shiraz, we've seen some new techniques like DTMA have a lot of potential to optimize phenolic extraction, but perhaps also needs to be very carefully applied when on a varietal basis. So more work is really needed in this area to understand the usefulness of these techniques. So I'd really like to thank you for your attention and your time. And I'd also like to thank a lot of other people. So please just note there, this work has been done over the last decade with a lot of collaborators, both at the AWRI, people who've moved on, people at the University of Adelaide, Grape and wine industry partners, and also our winemakers at the Institute. On this note, also just to thank our funding body, Wine Australia, who've supported this work for obviously decades, and to thank also the Oregon Wine Symposium organizers for inviting me. This has been a really great opportunity. I hope that I'll be able to see you in person in the years to come. And Oregon, I just think, is a fantastic place. You guys make great wine, and it's really great to be able to support your industry. So just moving on from there, I know we're going to have some time for questions. And so I'll wrap it up here and probably hand over to the guys to do their interviews, and we'll have time for some Q&A a bit later on. So thanks everyone for your time.
One of the things that we thought about with this session was that it's fabulous if you get a couple of researchers up here talking about phenolics, but as everyone in the wine industry knows, it really, really hits home when you bring actual people that are in the business of making wine and survive on successful wine production. It really hits home if they're actually utilizing these tools. And so as part of this session, we thought it was important to bring in a couple of winemakers to talk about this. So we're very, very fortunate to have these two fabulous winemakers. They're very much known in the industry for their skill and dexterity and their craftsmanship. First up is Sam Tannehill. Most of you don't need to get an introduction of Sam Tannehill. He's clearly, in my mind, an icon of the Oregon wine industry today. For those of you who are not familiar, I'll give you a quick intro of Sam. Sam is a Washington and Lee University graduate of Virginia. He's also earned a postgraduate degree at the University of Dijon in France. Sam and his wife, Cheryl Francis, founded Francis Tannehill Wine Company in 2001, and then A to Z Wineworks with their partners, Deb Hatcher and Bill Hatcher. A to Z Wineworks has grown quickly, and the families have acquired Rex Hill. They did that in 2007. This wine group has now become one of the largest wineries in Oregon, with a distribution in 50 states and 8 international markets. And I'm sure, Sam, you probably have an update on that. We're probably up to maybe 20 countries now internationally. But I'll let you add to that if you'd like. Sam is really known in the Oregon wine industry for his passion, as I said, his craftsmanship. And I think, in my mind, if you think about people who really take responsibility seriously, Sam is certainly doing that with the Oregon wine. He's very active in organizations that represent the Oregon wine industry nationally. He's clearly involved and wants to be successful, or feels that his success in the industry comes from the success of everyone else. And so he's involved in the education and research area as well as the marketing angle, and certainly the sales area for the Oregon wine industry. So Sam, thanks for coming with us. We're really lucky to have you, and thanks for being here.
Well, thank you, Jim, for that kind introduction. And before we get started, I just want to say again, thank you to you, thank you to the OWIS, and thank you to everybody watching today. It's an honor to be here, and I'm happy to share the knowledge or lack thereof that I've accumulated over the years about phenolics, because every time that it seems that we think we have a handle on something new comes up or something new presents itself, and another path for us to go down. And as everybody knows, that's what makes winemaking exciting. It keeps us on our toes. And I really think as we've moved forward over the years, phenolics have, as one of the building blocks of wine, have really become one of our touchstones at A to Z and at Rexhill, and something that we measure, something that we model, something that we manage, and has become an important part of our winemaking. Absolutely, for sure.
Yeah, I think you guys are one of the standout groups here in Oregon that definitely uses phenolic analyses in terms of wine production and making your wines such a success. How did you get there? I mean, what kind of instrumentation did you buy over time or acquire, or is your operation clearly dependent on outside laboratories?
Well, I think to start first, I want to give a shout out to Steve Price, who I've worked with for a long time, for many, many years, both starting at Archery Summit and all the way up through A to Z, for helping guide us with phenolics and what we're looking at. And so certainly back in the day, we used ETS labs a lot, and we still do for certain things. However, over the years, we've wanted to create models and ways that we can use phenolics in the winery, that we can get real-time measurements, that's actionable data, and things that are easy to do and are efficient and cost-effective. So the two instruments that we really rely on in-house right now are our spec. We measure 280 for total phenolics, 420 for browning, especially in white juice, and then 520 for our anthocyanin or color content. And we use another product or another machine called a colorimeter. I always have trouble pronouncing that. And that measures the visible color in the wine, and that we've only started using for the past 2 or 3 years, and that's been super helpful. Especially with our Rosé and our Pinot Gris program, but also looking at the wine as it ages, both during the élevage and then in bottle, and trying to predict what the consumer will see. But going back to the spec real quickly, we developed this algorithm in-house using really 280 and 520, that we can also measure what we would call tannin. And so moving forward with that, we've developed this ratio of tannin to color, and that's really helped guide our winemaking, especially during the fermentation, to fit to the style that we want at the end of the day. And I guess to back up real quickly, all of this phenolic work is in some ways service to the style. And the style especially with Pinot Noir that we're trying to make right now, is one that has a higher polymeric fraction, lower catechins, lower tannin, or a higher polymeric to tannin ratio, and then a lot of color. And so using that ratio really helps us out during the fermentation. We've seen really positive correlation between our numbers that we get on the spec and the numbers that we see from ETS. And these numbers in house, at least during the fermentation, because I know we're going to talk about other numbers at specific times. They're fast, they're real time, they're actionable, they're reliable, and best of all, they're affordable. The spec is a little bit of money, but once you get that down, really it just becomes a matter of time working with the spec. The other analysis. Oh, sorry, Jim. Go ahead.
No, that's okay. Please continue.
Well, I was going to say the other analysis that we use, that when it's not in-house, we use the rapid phenolic panel, the white wine phenolic panel, the grape phenolic panel, and the color profile that ETS offers. Less with the color profile since we got the colorimeter, but we have used that in the past. And so those are what we use in when we're using out of house, because we like to separate into quantity and quality, or type. And I feel really comfortable that we have the quantity down, but it's a little bit of a blunt instrument. I don't really feel confident, at least in-house yet, that we have the quality or the type of phenolic measurement. So we do send those out.
But you guys are such a large operation, and obviously you purchase a lot of fruit. Do you use this analysis to provide feedback to growers in terms of a phenolic profile? And how successful is it? Is it becoming an objective measurement from a vineyard perspective?
Yeah, absolutely. So I think that there's two ways we use the phenolics in the vineyard. One that we've used for quite some time, and the other that we're trying to breach a new frontier. So the one that we've used for quite some time is we take a lot of samples at time of harvest from the vineyard, and they're grape samples, and we use these sort of retroactively or looking back. So at the end of harvest, we generally freeze those samples, and we'll take them, send them out for analysis, do a phenolic profile on them, look at the corresponding numbers in the tank, because we'll be running the phenolic analysis once those grapes go into the tank. But a lot of times those are blend. You know, when you're fermenting in 20, 40-ton tanks, some vineyards tend to get blended in. But then we'll go back with the grower, or even with our own vineyards, and say, okay, what were we trying to achieve in the vineyard? Did we achieve that with our phenolic analysis? You know, or it'll be a justification of perhaps experiments or different viticultural techniques. And then especially with growers, we'll look at it and say, okay, here are over the past 5 years, here's your phenolic analysis, and here's how you've improved, or here's how we've seen a little backslide. And why is that? Is it a function of the year? Is it a function of viticulture? And then we'll actually show the growers where they stand in the midst of all the other phenolic analysis. So, you know, that what I think really helps define a relationship is when you can put real numbers to it. You know, in the past we've talked about quality, but it's really hard to put those numbers, and it's become easier with this phenolic analysis to say, hey, this is what we're looking for. This is actually the numbers that we're looking for, the ratios that we're looking for from your vineyard. And, you know, gold star, you did it, or we got a little bit more work we have to do. Now, the second tier that we're trying to adapt is trying to figure out, you know, we're all looking as winemakers how we bridge that vineyard to winery, how we create that vineyard to winery bridge. And when you look at harvest numbers, we talk a lot about taste or bleed out or seed color or Brix or TA or pH. And we've been trying to develop a program that looks at phenolics in the vineyard and how that's going to correspond to what we have in the winery. So we look at extractability, we look at catechin, we look at polymeric phenol load, we look at a whole bunch of other different characteristics. What we haven't found is a particular tool that'll help us get that information inexpensively and in real time. So we've done some trials. We found a lot depends on the year, you know, especially catechin, how many seeds, how warm it is. One of the things that we're going to that's a little bit easier now is berry water content and berry size, and we're finding some strong correlations. Again, not with type of phenolics, but with let's call it the phenolic load. And I think lastly, what we're looking at is we're correlating regular phenolic results we see to certainly exposure and altitude and aspect of a vineyard, but we're also seeing a lot of correlation with water holding capacity and the percentage of clay in the soil. So phenolics have absolutely helped us select the vineyards that we want to work with our program, again, shooting for a particular style, which for us, again, is higher polymeric phenols, higher color, and lower tannins. And hopefully those phenols will be made up of less catechin at the end of the day, because that's just something that we're not looking for, but something that we struggle with up here in Oregon.
Sure. Briefly, how about in the winery? What are you doing in the winery to manage, Tim?
Boy, briefly, right. I know we don't have a lot of time.
We've got 2 minutes, Sam. No, this is great. This is great.
So one of the important things that we're doing in the winery, we'll separate maybe to whites really quickly first, because we can go pretty quick there. One of the largest phenolic loads that we've seen is when we're mechanically harvesting Pinot Gris and we bring it up from a far away vineyard. So that's helped us determine when we pick and how we pick with those vineyards. We're looking at pressing, but it's really hard to stop a press cycle, go run some spec numbers, and come back and continue. So at one point, we tried to correlate pH with phenolic load from the press pan because we could have pH measurements right there, and we haven't found a strong correlation. Otherwise, what we use phenolics for with whites is, especially with rosé, is taking a look at the colors and predicting what the colors are going to be as the wines age in bottles. So that's where the color emitter really comes in handy. The other thing that we found is sometimes Pinot Gris can give us pink wines, and so we measure the phenolics there, and we see how much free sulfur we're going to have to hide those phenolics over the length of time in the bottle, so we don't see, not pinking, but so we don't see that color pink coming through. Now with Pinot Noir, phenolics play a large role. They, when we bring the grapes in, we run the phenolics, and then again we look at the spec, and again the 280 and the 520 during the cold soak. And we find that there's a time in the cold soak where the color actually begins to descend, and that's generally speaking where we launch our fermentation. And then we try to modulate the tannin in, looking at those numbers, and again that ratio. And so when we hit the ratio between tannin and color that we want to press, we'll go ahead and press. And sometimes we'll press as much, like in 2018, at 10 brick. Sometimes we'll do some extended maceration or some post-maceration, post-dryness. It really depends on those numbers, where that's really helpful. And a supplement, not a supplement, but it helps with our tasting, because those ferments have so much sugar that they can tend to hide the tannin. The other thing that we look at, and again, we're trying to create this ideal wine that we've said, okay, here's our goal. We almost never get there, but we're trying to create this goal. And at 10% of the combined blend, we'll run at every 10% of the blend, we'll run a phenolic profile and see where we are. And what that'll do, a rapid phenolic profile of our blend. And what that'll do is that'll help us think about when we need to be picking the next lots coming in, when we need to be pressing those next lots, how much we need to be extracting. Do we need to increase the temperature? Do we need to lower the temperature? Because those will show us how much polymeric phenols do we have, how much tannin, how much catechin. Because at the end, we're going to have one wine, our A to Z Pinot Noir, 120,000, 150,000 cases. And what we want to see is where each tank, where each component fits into that larger puzzle. And so that 10% sort of stopgap at every, 10%, 20%, 30%, measuring the hypothetical blend and the rapid phenolic assay, doing that really gives us a roadmap to where we want to end up. And then I think, the other thing we've been looking at, I'll give you a practical example, and that is we were trying to look at pulse air versus digging out, pulse air slurry versus digging out a tank. And again, when you're dealing with 20 to 40 ton tanks, digging out a tank is, number one, it's dangerous. Number two, it can take quite a bit of time. So, but we've always done it because it was traditional and that's what we wanted to do. But looking at the phenolics between tanks, several years between tanks where we have dug out versus creating a pulse air slurry, we saw no phenolic difference between the two. So now we create a slurry with the pulse air. It comes out of the tank. We're able to pump it out, and we can dump a tank in 15 minutes where previously it took us an hour or 2 hours. So, that's a direct effect in our wine.
Wow. Those are some really good applications. The sad thing here is that we only have 15 minutes.
I know.
How do you get a winemaker in front of a camera and have stop after 15 minutes?
I know.
It's crazy. No, this is really interesting, Sam. One last question I have for you. A lot of people in the audience right now have not done phenolic analyses. They're really interested in it. They'd like to give it a go. What kind of advice would you give them in terms of how would they get started in something like this?
Well, first of all, I think the most important thing, a winemaker on our staff, Olivier, the other day said to me, hey, look, I just heard something that I think is really important to our phenolic program, and it's 3 words. It's measure, model, and manage. And that really struck me because, one thing that Steve Price really taught us is if we're going to do experiments, they need to be written up. They need to have really solid protocol. You need to follow them to the word during harvest, and then you need to review them afterwards. And so that's my number one key point of advice is have an experiment, measure the numbers. It's awesome, but get the numbers that you think that are going to affect your behavior and change your behavior down the road. Create a really good protocol for that experiment or the reason that you're getting those numbers, and then review those numbers post harvest. We have a tendency as winemakers just to collect data, and because it's cool and to see those numbers, but so many times that data just ends up on a shelf. You got to make sure you go back and look at it, and it's in service again to what you're trying to achieve, whether that be style, whether that be vineyard. So create those protocols, do those experiments, and then create those models that work for you. What we do at A to Z may or may not work with other folks, and you got to create what works for you within your system. Because if it's difficult, if it's expensive, if you're reluctant to do it, those things get lost along the way. And I've seen that happen even to me over the years. And then, the other thing is develop a language that you can talk about with your staff, with your winemaker, with yourself. When we talk about phenolics in the winery now, because we use a spec, we talk about absorbance units. We don't talk about milligrams per liter. And we all know what we're talking about, and we all know the ratio. And that really serves us in our system. And then lastly, there's no golden bullet. Phenolics are awesome. I love them. Obviously, I'm passionate about them. I use them as one of the key building blocks and things we need to know about. But there's no substitution for tasting. There's no substitution for walking your vineyards, putting grapes in your mouth, putting wine in your mouth, and using the phenolics to support your decisions, but not having them come as your sole decision. It's really tempting to come up with the magic number, and trust me, I'm tempted. But that's a false path as well. So that's my advice for moving forward. And good luck. I think it's the more that we understand about our building blocks of our wine, of the black box what's in our wine, and the more that we can share it. Anybody can give me a call. Anybody can send me an email. I'm happy to share what I've learned. I'm happy to share what we've learned. It's only going to make the Oregon wine industry more robust and have higher quality wines.
Well, Sam, I think those are very good words of advice. It's been a real pleasure to spend some time with you. I wish we had a lot more time, but thank you so much for spending time with us. I appreciate it, and I'm sure the audience does too.
Thank you, Jim. Thank you for the time. And anybody, Jim, you're welcome to come up and taste with us at the winery anytime. Well, maybe after COVID. So
fair enough. Thank you, Sam.
Cheers. Thanks so much.
So our second winemaker that we have today is Michael Therrien. I've known Michael for quite some time. Geez, Michael, I look back on my notes, and I think we've known each other for like 30 years. It's just a long time. So it's great to see you. You're looking good. For those of you who don't know Michael, Michael and I got to know each other at UC Davis. He's a graduate of the UC Davis winemaking program, and he spent some time at Acacia, and he was a winemaker at Hansel. And he then moved on. He started his own project, Therrien Wines, and he's a winemaker for a number of different projects. I'll let Michael get into that, but he's been quite successful, and he's certainly on the cutting edge of things in terms of getting creative. And I'll let him explain more of that as well. So, Michael, great to have you. You're looking fantastic, as I said, and thanks for spending some time with the Oregon wine industry.
Great to be here. Thanks for having me, Jim. Nice to see you.
So I thought we could start by saying, I've known you for quite some time, and I know you've looked at phenolics for a long part of your career. Can you tell the audience, how you got into a phenolic analysis in the wine industry, and how did you start with all this?
Well, I guess probably thinking about the preamble there of how long we've known each other for, it makes me think I might have 25 vintages done now, and maybe another 20 to go before I'm useless. The eagerness that I had to understand what was happening in a maceration with Pinot Noir, particularly at Acacia in 1997 when I got out of UC Davis, was replaced over the years by sort of a passive, intuitive approach. And I think maybe maybe, talking with listening to Sam and hearing how my days at Acacia, a publicly traded company back then, Chalon Wine Group, and the desire to make wine that really needed to be sold in Costco within 24 hours of rolling off the bottling line. Like there was a mandate to make that wine good, and we had an approach to fermenting and maceration, which was about getting that tannin out aggressively with heat and punch downs, and using analyses. In that case, it was with Jim Harbitson, who was a student still at UC Davis, and he had been working on developing the Adams-Harbitson assay. And did I say it backwards? So it was a useful tool that we had available to us during those first harvests that I was at Acacia. We just used it like crazy to pull out all sorts of good data on all sorts of fermentation techniques. And that I think stocks my brain up with enough understanding of what goes on with temperature, maceration technique, duration, specifically with Pinot Noir. That was a good start. That got me off going pretty good for a few years.
Wow. So were you finding that there were specific aspects at that time that you found where phenolic numbers were indispensable, where you actually said, all right, this number has value. This is clearly helping me make a product that the winery wants to make?
Yes. And going to Sam's points about how sweet it is when you press, how sweet a maceration might be, and a particular point might obscure your ability to taste tannin. So correlating the final result of that wine with your palate some weeks or years after the analysis during maceration, when you've got all the sugar and plenty of tannin perhaps, but you don't know because that sugar is obscuring it. It was really helpful to see that tannin build up and know you got to cut it at a certain point. It was interesting to come to Hansel after Acacia and look through Bob Sessions' notes going back to the 70s, where he was pressing at 9 bricks sometimes and making these monstrously tannic Pinot Noir that we understood. That was with Ryan Hodgins and I were looking at that data that way too, and understanding that it was really about the machinery, that Valley Foundry destemmer crusher. Actually, it was a crusher destemmer, and it had
we had one of those at a winery I worked at.
Did you?
Yeah. Oh boy, Mission Bell, yeah,
so
100 tons an hour, no less.
Well, Bob was realizing that he had this equipment that would grind up the whole cluster's stems and seeds, not a gentle thing, and it would liberate a lot of tannin just in that process before you even started fermenting. And to work with new equipment, and when I arrived, it was to transition from the old ways to a newer set of equipment, modern equipment, and using the analysis to understand how to replicate some of Bob's work, but also adjust to pull out more tannin, because the machinery wasn't doing it. It wasn't physically rending the skins and seeds and stems in such a way that it would liberate the tannins. You have to think about it from the chemical methods of just heat, alcohol as a matrix, and duration of maceration and punch downs and all that too.
So, it sounds like, right now, we talked about this last week, where you don't have at your disposal, the budget to do a lot of phenolic analyses, and yet you very much have utilized your historical background with phenolic numbers to help you be more intuitive with how you produce wines today. Can you talk about that a little bit?
I think even if I did have a budget, I think it's more like the type of wine that I'm making now, unlike when I was at Acacia and the requirement that it be a certain style and fit it into a spot in the marketplace. The wines that I'm making now, I'm fortunate to be in a situation to be able to pursue a very age-worthy Pinot Noir from a project in the Santa Cruz Mountains, particularly that I'm thinking about, where I had perhaps an about face on, rather than pulling everything out through duration, more like higher temperatures and punch downs through a passive approach to it. And I don't really know how I ended up there, but I actually am curious, Jim, from talking to you, what you might feel happens in a very cold maceration, whole cluster maceration, over the course of a month. And that is the technique, if you, or lack thereof, that I've been applying in order to build up structure in tannin that is very much like a Nebbiolo kind of dry tannin, or the pinch at the end of espresso shot. And that's what I'm going after, rather than the voluptuous, generous tannins that were the mandate at Acacia for longevity.
Yeah. I mean, we did some projects in Napa Valley where we did some very long soak times, and it was certainly to the point where the cap was sinking. It was gone. They were just turning things over periodically to get tank mixing. And one of the things that we did find was that the size of the tannin really got smaller, but there was a lot more tannin, and it was seed tannin. And it definitely moved beyond the realm of bitterness and more than just to a Nebbiolo type of a dryness that oftentimes the winemakers were looking for. Instead of that fleshiness that you get with, a high temperature, short time sort of a soak. And so, yeah, no question. But that's that's a style, isn't it?
Right. And, there's room for all types of wines. In this case, it's an expensive wine with a potential to be aged for decades, and that's what we're pursuing. A very different mandate than Acacia in that time, and for many Pinot Noirs, which are just pop and pour and be delicious. This is not needed to be delicious in its youth, and would like to be set up for the long haul. You spoke about the small tannins in a longer maceration. Is that due to seed tannins being smaller, or is it due to a fining process within the maceration?
One of the things that we found is that as your fermenter soaks, you're no longer generating heat. And you're moving into the colder months and such. And so unless there's a deliberate attempt to keep that fermenter warm, it's going to cool off. And a lot of times you've got all the solids in that fermenter. They literally start fining the wine. And so as they're dragging out tannin, and they tend to drag out larger tannins, and you can see that anytime you do a fining experiment, if you add some protein to a wine, it drags out the larger tannins, and you can actually get some short-term bitterness because you've taken away that mask. And it's the same thing that we see in these other fermenters, where these larger, perhaps skin tannin only things are fining out, but you're still getting extraction from, you've got these big sinks of tannin that are slowly extracting still. And so there's this real constant interplay of, tannin going away and tannin coming in.
And then those smaller, oligomers, or little smaller bits of tannin pieces that then over the course of bottle aging might join up and become quite different in their
Exactly. And I mean, we all know that, there's a slow oxidative process that happens with wine.
Yeah.
A lot of that's oxidative coupling of these phenolic molecules.
Well, I feel like, I'm never going to be in a position like you are and other researchers to keep looking deeply into the ultimate mysteries of aging red wine. But my intuition, what is it? It's just another word for the supercomputer in your head, but doing it unconsciously. And I feel like there's something to the approach. It feels right, and I know that's not very satisfying. Perhaps the people listening would want the reasons for that I was chasing after. I mean, I remember in an analysis at Hansel we had these great little tanks, these custom built tanquitos, we called them, which were 1-ton fermenters that had sort of pressure cooker tops you could screw down and just put things away forever. We did that, and we wanted to see with the tannin assay just how long can that extraction continue? Does it run out of stuff to extract? And by that 2-month extraction, it never ran out. It just went up and did not make a good wine, but it was interesting to see that it really didn't plateau at some point as far as that particular assay, which measures precipitatable tannins.
Yeah, and there's some very old data out of France, River of Gaillon, same sort of thing. These massive Bordeaux wines, soaking them forever, and they're still giving up tannin. So, yeah.
Well, I was impressed when I started this work in Santa Cruz Mountains with the concrete fermenter that's shaped like a teacup. I'll quickly pop this up here so you can see what I'm talking about. But it's holds about 1 ton.
That's cool.
Really nice thick concrete. It's the top half of the egg, the Sonoma cast stone egg, and Steve there turned it upside down and blocked off the openings. So I just leave that fruit in there and punch it down with my hands to get it below the surface, and then cover it with one of the canvas tops and leave it alone without anything, no acid addition, no water, no yeast, no nothing, and just leave it alone for I don't know, for the better part of a month. And it started off by just being a week-long maceration, thinking it's going to be really tannic. Wasn't. Went to 2 weeks, went to 3 weeks, 4 weeks. I can go to 5 weeks still and not get something that's abusive to the palate.
Amazing.
Really interesting, because you're talking about a lower temperature extraction, and it's whole cluster, which a lot of the juice is bound up still within the grape, rather than as a matrix to extract.
Yeah, that's cool. Yeah, we've only got a couple of minutes. Can you tell me a little bit about your project in Maine?
I was born and raised in Maine. Thanks for asking, Jim. It's good you asked with only a minute left, because I could go on. It's wild blueberries are the fruit of Maine, the iconic fruit of Maine. And it occurred to a friend from 5th grade, and that we wanted to hang out in a barn and make wine out of blueberries, wild blueberries. And so we did that a few years ago, and it's turned into a business. Wild blueberries turn out to be a low tannin, low mouthfeel tannin, if you will. It doesn't have a drying effect on your mouth, at least, but highly pigmented fruit with good acidity that we make a bubbly wine out of, a method champenoise wine. And that has been really interesting I think probably relating to the way I'm thinking about U.S. Grant Pinot Noir and that teacup. Don't come to a new project with preconceptions from your history of making wine. Take the fruit from Santa Cruz, Pinot Noir in that case, take the fruit from Maine, wild blueberries in that case, and learn a totally new approach.
So it sounds exciting. It sounds exciting.
Very fun. Yeah, it's an invigorating thing for my midlife crisis.
Well, I think that's really cool. I really do. And, I wish we had more time to talk. I mentioned this to Sam as well. And it's, I enjoy talking to winemakers, because you guys are, to me, the ultimate in passion and craftsmanship. You're going to introduce us.
My conference room has been taken over by the person who actually occupies it most of the time. This is
Hi there.
Hi.
Well, it's really good to have you, Michael, and you're looking great, and I hope to see you again soon sometime.
Great. All right. Take care.
Take care. Bye-bye.